Hi, good morning everyone. Hope everyone is doing good. Yeah, today we are going to present a webinar on ThingsCloud Inverter applications, both ZD like zero export and three-phase systems with the single-phase inverters. So ThingsCloud basically a tech company. We are engaged into developing power electronics products. So solar inverters are one of our vertical, and we have up to 5 kVA grid tie inverters and grid hybrid inverters, and also we develops other UPS and all these stuffs. So like 2015, and then we were in doing like all R&D, and we have come up with a product in early 2017, and we have started field trials and certifications, and by end of 2017 we have come up with all the certificates and products. So this is a small introduction. So this is our team, like Mr. Amrut and Anushil is founded ThingsCloud Technologies, uh, and myself Vasudevan. I'm leading I'm heading the sales, and Mr. Rohan is our growth head. And this is our ecosystem, like our product chain. So basically, our product, where all the areas we are working on, like one is the solar sector, and one battery based system, and grid connected system, and Wi-Fi for the monitoring purpose, and cloud for storing the data. Whatever we are getting from inverter, we are storing the data in the cloud and we are processing it. And mobile application is for monitoring the system. So our presence, we have a R&D center here in Kalyan Nagar, Bangalore, and the production is in Whitefield, Bangalore. This is a glimpse of our R&D center, and this is our production facility, and we'll just go through that production plan. And Things Wi-Fi is our Wi-Fi module, which will connect to the inverter and communicate to the cloud, and whatever the data which is showing in the system, it will be pushed to the cloud. So you can monitor the system through your app or web dashboard. So, and you can also process the data, whatever you are getting. I mean, whatever is there in the cloud, you can utilize it. And ThingsCloud is nothing but an Android app which interact with the device, and we can monitor the system like wherever you are. Only thing is you should have a internet connection. So our first offering is our Things HiFi. So Things HiFi is a grid tie inverter. So there are three variants: 1, 3, and 5 kVA of single phase. Okay. And these are high frequency model design, so transformerless design basically, and it is comes with a built-in AI. So Built-in AI is, what is the built-in AI? AI is a artificial intelligence. This is basically a boost algorithm which helps to ensure that you are getting the maximum yield out of solar. So if you are connecting a system, so the end customer, the ultimate aim is they have to utilize the maximum from the solar, right? Because the investment is more, so and they spend a lot of time, and they kept the system on the top of the terrace, and they want to get the maximum output from it. So this is basically, this is so our inverter which ensures that you are getting the maximum output through, with the help of AI. And zero export device. This is an optional thing. There are normal grid inverters. So whatever you are generating will push back to the grid, or you are selling back to the grid. And so for that you need to have a bidirectional meter. So you have to get approval from the discom, and you have to get that. So zero export is another option, which is like no need to go for the approvals or something, and bidirectional meter. So existing like unidirectional meter, you can use that. But I'll explain about that zero export feature later, because that is the main agenda of our webinar today. So built-in load sharing algorithm, this also I'll explain later. This is nothing but the load will be shared among grid and solar, and cloud-based monitoring. So as I said, when we have to, for the monitoring purpose, we are connecting the things Wi-Fi to the inverter, and whatever the data which is there or which is stored in the inverter will be pushed to the cloud, and we can monitor through your mobile app or web dashboard. And we have a with the help of the high quality algorithm, MPPT algorithm, and high quality components which we are using in the system, we could achieve more than 99.5% of MPPT efficiency. And in the next version of our things HiFi inverters, we can accommodate bifacial panel as well. So bifacial, nowadays all are going for the bifacial panel because of the space constraint and the efficiency of the panel, right? So the next version of our product will be accommodating those type of panels. So this is a typical system diagram of a grid tie system. So here this is our solar panel. From solar panel to DCDB connected to the ThingsCloud grid tie inverter, and this inverter converts DC into AC, and it will push to the load. So it will be like a single connection where you have a bidirectional energy meter will be there, and your grid connection is there. So whatever the consumption is there in the home, so that will be taken care by the whatever the generation, and if the balance is there, it will taken from the grid. So in that case, and if there is a excess energy, whatever it generates, it will goes back to the grid. And inverter, this things Wi-Fi is a Wi-Fi module for the monitoring purpose, which is connected to the inverter, and from that it will, whatever the data is there, it will push to the cloud, and from cloud you can monitor through your laptop or through your smart devices. In this case, like in all the grid tie inverters, it needs a reference from the grid side. So if the grid is available, it will whatever there, it will push. If the grid is not available, it will be like an idle stage, like it will be turned off. So these are the basic certifications which is mandated by MNRE. So we have got all the certifications for all our 3 models. So the basic, today that agenda is to explain the use cases of our things HiFi grid tie inverters. So there are two things, like one is our zero export, and other one is a 3-phase systems with a single phase inverters. So first we'll go through the zero export application. So as I said, when you are going for a solar grid tie system, So first you need to get approval from the discoms, right? If you are in Bangalore, it is Bescom, and if you are in Tamil Nadu, it is Tangentco. Okay, if it is Kerala, KICB. So you have to get the approval from them. Then they will. So you have to apply for that. Then they will come and do the feasibility study on your premises, and they will say, okay. Then they will give the approval for. Okay, you can go for the system. Then after that, you have to get the bi-directional meter. So in normal case, if you think of the system, like, it is very easy process. But when it comes to the reality, so it takes a lot of time. So sometimes in some places it is taking from 3 months to 6 to 8 months. Like, say, 3 months to 6 months is the practice, and sometimes it will go beyond 6 months, like up to 8 months it may take. So in that cases, you are not supposed to send any generation to your discount. Okay, if they found you are doing that, then they will come and penalize you. So it will be a headache actually. Even though after investing so much on the solar, and if you are not getting the approval, it's a pain point, right? So that is why we have come up with the zero export systems in the inverters. So the first point, if you look at that, there is no hassle of Netmeter or approval. That's what I'm saying. So you have to you have to applying that. Then they will, once you get the approval, then they will give a bidirectional energy meter to replace the unidirectional energy meter which is already existing in the home, right? So in this, what will happen if there is a bidirectional meter, right? So whatever, if you are consuming, so it will, like, say, if you are considering a disk, so it will move in a forward direction, and if you are selling back to the grid, it will move it in a reverse direction. So like, say, the net, so they'll charge that 120 units extra. So that's what we are saying, that you have to go for a zero export system. So many places where so the second thing is, like, many places where this net meter will not available, or after installing a system, and they want to like add, like, their consumption is not that much reduced, so they want to have more panels or more system, more like, say, one hospital, they have a 10 kilowatt system and they want to add 5 kilowatt more, but sometimes they won't give the approval for it. So such conditions, you can utilize this zero export system. And another advantage is, like, you have all domestic sector, you are having the slab rate for the electricity, right? So from say 0 to 100 or 0 to 50, some places it is less than that. Like, in when you consider to Bangalore, it is up to 30 units, it is 3.75. So from November onwards, they have increased to 4 rupees per unit. So they have added 25 paise per unit. So then after 30 to 100, it will be 520. So now it is 545, and 100 to 200, it is 6.75. Now it becomes 7. And after more than 200 units, it will be like a 7.8. Now it is 8.5. So 8.05. So whenever you are using more and more, so your slab is changing, and you have to pay extra for whatever you are consuming more. So in such conditions, if you are having a zero export, it will reduce the your generation consumption from the grid. So like, say, from 100 units, like, say, 200 units, you have your falls under 200 unit category. Then what will happen if you are generating 120 units, right? Then you will fall down to 80 units. 80 units means for first 30 units you have to pay for 3.75, and balance 50 units to pay for 5.20. So you no need to pay that extra. So I'll show you that those calculations in when we are discussing about the ROI about the system. Okay, then educational institutions like commercial spaces where they have a daytime load. So nighttime they will not be using much like in the schools and all. So that daytime they'll be having the load. So whatever generates will be like nullify or they can reduce the consumption. So that is the one like an use case. And there is a like the spaces like the places like say small clinics, beauty parlors, medical labs, so petrol bunks, so wherever they have a daytime load, they can go for the zero export system. And also the diesel consumption, but this 5 kilowatt, 3 kilowatt, it won't be much difference when it comes to a diesel generator, because most of the places the diesel generator will be like 600 kVA or the 750 kVA. So in such cases it won't make much difference, but a small system at least we can reduce the diesel consumption from the load, from the DG. And this is the typical system diagram of a zero export system. So there is a small changes compared to the GT system. So here this part is like this part is it is like same. So there's a panel, there's a DC-DB, and it is connected to the inverter, and inverter ThingsCloud inverter will convert this DC into AC, and it will push to the cloud. Oh, sorry, push to the home. And there is a, so here in this inverter there will be a two port. One is AC in and one is AC out. So AC in will be connected to just after your normal energy meter, that unidirectional energy meter, and it is connected to the inverter. And there is a out point which is connected to AGDB, and it is going to the loads. So we are consuming here. So this is the typical connection diagram for this zero export system. So you have to connect the inverter just after the energy meter. So this is the connection diagram. So there's the panel, so there's the DC-DB, and here you can look at the marking like AC in. So this is where our power grid, like the grid is connected to AC in, and there is a AC out which will be connected to the load or HDB, whatever. So here and there is a communication thing. So IoT is connected to the inverter, and it is pushing all the data to the cloud. So here we will discuss different scenarios of zero export system. So at like now by the time you will be having a doubt, like if I'm generating more, what will happen? If you are generating less, what will happen? What will happen to my load? So all these things that we will discuss in the coming slides. So the first condition is your generation and consumption is equal. Say you have connected 1 kilowatt system. So for the explanation purpose, I'm saying that from the 1 kilowatt system you are getting 1 kilowatt output. Okay. So you have 1,000 watts of load you connected to the system, this ZD system. So what will happen? So whatever is generating, that will goes to the load. So that's all. Whatever is generating, it is going to the load. So no, there is no export is happening here. So here is the example. This is the graph which we have one of our system which is installed in Bangalore. So if you look at here, okay, so there is a total load. They have 593 watts. This is a 1 kilowatt system, 593 watts. That means output power means it is from solar, and grid power is from grid. So grid power is it is taking very less, like 9 watts, and output it is 584. That means it is coming from solar. So there is a sharing is happening in between grid to solar. So this is how they are now the daytime load. Whatever, if you look at here, like all this yellow, so almost it is equal as the output power. So the daytime load is like mostly the daytime load is supplied by the solar system. Only now if you look at here by 550, 516, it is come down and it is almost zero. So maybe there is no much solar, so that's what happened, and this AC power goes up here. And condition 2, like your say I'll tell you, like you have a 1500 watts of load connected to the system, and you are generating only 1000 watts from solar my load. So the 1000 watts which will be supplied from the solar, 500 will be taken from the grid. So your consumption is reducing drastically on these conditions. There is no export is happening, right? Now we'll go to that here. Output power is around 420 watts, and grid is 208, and output power is 212. So from solar we are getting only 212 watts, and balance 208 is taken from the grid. So that is what we are sharing the load here. Now condition 3, like so this is not an ideal condition. So whatever we discussed about this condition 1 and 2, these are the ideal conditions where you are utilizing the solar at the max. But here, say you are generating 1000 watts and your load is just 800 watts. What will happen to that 200 watts? So it will be wasted, right? So it will be wasted. There is no doubt in it. But here what we are doing that with the help of our algorithm, with MPPT algorithm, we are controlling that input, and we will generate only whatever the load you have connected to the system. So say you have connected only 800 watts and the system is solar is generating 1000. So our algorithm will convert that into 800, and only 800 will be supplied to the load. So this is that condition, that output power. So output power is 659. This is 659. So it, like in this condition, like now we can say like this is a 1 kilowatt system. So most of the time it is generating almost 800 to 850 watts from that. So from as they have only 659 connected load, then it will be limited to whatever they have connected. The load is there. So that's what they say. It become 659. And the condition is the fourth condition. If there is no grid, then the system will shut down, and there won't be any generation. So now export will happen. And there is one more use case with that. One more tip we can give. Like at the output of the AC out, right? At AC out of the ZD inverter, we can connect the UPS in. So whatever generating, like either it is a normal UPS or online UPS. So that output will be connected to the AC in of the UPS, and whatever is generating will be like either it will goes to the battery or it will go to the load. And if there is a power cut, so for the critical load, you can utilize it as a backup. This is basically for the existing UPS customers. So we'll go through the ROI, return on investment on. Actually, I'm just considered 2 states. One is Maharashtra and the other one is Karnataka. So domestic. So this is the domestic thing. So here I'm just considering 150 units, 200 units, 250, 300 and 350 units. Okay, and there are these are the common components which will be there in your electricity bill, like fixed charge, energy charges, wheeling charges. This is all based on the energy, how much energy you are utilizing. how much energy you are consuming. Based on that, it will be. So wheeling charges, like you have to pay 1.4 paise for 1 rupees 45 paise per unit you have to pay. Okay, and electricity duty, and there will be 60% of tax on that. So for a 150 rupees, when somebody is using like 150 units, so they have to pay around 1201 rupees per month. Okay, so here I've connected a 1 kilowatt system, zero export system, and it is generating 120 units in a day. So here, so you have to see billable units. So whatever this is your consumption, and you are generating already 120 units. So you have to, you can now you can minus from 150 to 120, then only 30 units you are billing. So your electricity bill will be 286 rupees, and savings per month will be 900 plus. Okay, and in a year you have to pay, you're saving almost 11,000 rupees, right? So typically a 1 kilowatt grid zero system will be costing around 50,000, 50 to 55,000 it is. So in a 4.6 year you will get the ROI. So whatever the investment you made, you'll get it in 4.6. And like the same way, there's the 200 unit is the 250, 300, all cases when it comes to whenever. So if you look at here, when your consumption is more, then your ROI is coming down. So that is the beauty of this system. So you can utilize this this zero export to reduce your current bill, and in like for those who are having a higher usage, for them it will be a very useful, like just 2.5 or 2.4 years they'll get the money back, they'll get whatever they invested. Now we'll consider the commercial bodies in, again this is the Maharashtra. So here if you look at that, it is almost so because in commercial side there is no slab rate, so for them it is like a flat rate. So whatever the unit they are consuming, they have to pay some 9 rupees or 9.5 something you have to pay for it. So you will get a ROI in 3.3 years. So like the places, like the commercial places like this doctor's clinic, labs and all this stuff, all these places we can go for this. And now when we are coming to Karnataka, okay, so this when I did this ROA, like I just consider Bangalore. So here you have to pay 851 rupees. So I didn't consider this taxes and all this on this, right? Yeah, taxes is there. So total 928 rupees you have to pay for a 150 units. So if you are consuming 120 units from the solar, so you have to pay only 30 rupees. Sorry, only for the 30 units. Okay, so your electricity will be 124 rupees, including fixed charges. So here, if you can, you are getting almost 804 rupees, like 804 rupees you are saving, and in a year it will be 9,600 plus. So here it is like the in the smaller sector, like the ROI is like 5.2 years. When it comes to this 350 unit, or those are using more, so their ROI will be like 4.6. And then comes to commercial, it will happen in 3.9 years. So you'll get the money back in 3.9 years. So these are just for your reference I've given. Okay, the second use case, like yeah, as you all know, like there is no three-phase inverter less than 5 kVA. So some places like Tamil Nadu and all that that Tangerco, they have mandated that those who are having three-phase connection, they have to go for only three-phase inverter. No matter whether you have enough space in your roof, or what say you have enough consumption, you have to go for three-phase system. So that means a lot of lot of people, they have stepped back because of this issue. Because even if you are connecting only 2 kilowatt panel, because one particular place, they have only two, they can only accommodate 2 kilowatt of panel, say 6 panel, 330 watt peak or 335 watt peak. What will happen? This 5 kilowatt inverter, 5 kilowatt three-phase inverter may not give the maximum yield from that, because you will not actually that inverter will not be able to maintain the AC that AC level. So that condition, even though if you are install the system, it won't make any sense. So that's what we have come up with the new proposal, like single phase inverter. Our single ThingsCloud single phase inverter, like a 1 kilowatt inverter, you can connect three in parallel, like in every phase. Each phase will have a ThingsCloud inverter, and it will be connected to a common communication, and you can see or whatever how much energy is being generated, all these details you can see it in your app or web dashboard. So, and there are multiple advantages to go with these kind of systems, right? So here, like I'm connected, like in this we have a tolerance of 1.7 kilowatt, so almost it will be equal to 5 kilowatt three phase. So you can play around between 3 to 5 kilowatt, right? And main advantage, so it is connected like in each phase. The first inverter is connected to R, and the second is connected to Y, and the third one is connected to B line, and there will be a bidirectional energy meter. And also you can for a grid zero for this system. If somebody is not getting the approval, you can go for zero export as well. So the advantage of system. So here we have individual inverter in each phase, right? So the generation, so you have a multiple MPPT. So don't need to go for like if there is, if anything happens in the string, or some kind of partial shading or something is happening, then it will affect only one, not all the whole string. So we are having a 3 strings here, and normally, like most of the cases, like most of the places, we are facing one issue, like all the time 3 phases will not be available, only 2 or 1. So in that cases, what happens? The normal 3-phase system will get shut down, right? So here, as it is an individual, we are connected as individual. So even though one phase goes off, other two will be generating the solar power, and it will push to the load, or and it is very cost effective compared to this 5 kilowatt grid 3-phase inverters. And our next advantage is like the service downtime. It is very less, because if a 3-phase inverter shuts off, all the three phases will be shuts, and it will not generate anything. But here, if one phase, other two will be generating, and you can just replace the one unit. So that is the advantage. There is another use case. This is like a windmill or hydro. So the thing is, it will be a DC out, which will be connected to the inverter, and rest of it will utilize, like instead of solar, we can use DC hydro. And these are very efficient and cost effective. This is the main advantage of this system. But this is not that popular. And this is the ThingsCloud Wi-Fi, which we are using it for monitoring the system. So it will be connected to the inverter Wi-Fi, and whatever the data which is fetching from the inverter will push to the cloud through Wi-Fi. And if there is no Wi-Fi or some outages in the internet connection card, which is inside the system, the memory is there inside the Wi-Fi, so it will store the data, and whenever the network resumes, you will send all the data back to the cloud. So here we are ensuring that even though there is a net outage or internet issue, you are not losing the data. So this is our ThingsIO mobile app. And this is ThingsIO web app. This is our like we have given many interviews and many informations which came in the media. So I'll just go through it. This is the article which came in your story, then Entrepreneur India, Indian Express, and Techie Expert, then Times of India, then Sour Energy. So almost all leading newspaper platform we got they have taken the interview, or they have because it's a new thing which is there in India. So that's what we got, a lot of coverages. And these are our client list. So you can see almost all prominent customers are there. And this awards and recognition. So we are the official design partner for Infineon and Microchip to develop innovative solutions. So as we are a tech company, so we got a chance to develop for them, like a design partner for them by using their components. So most of our critical components are from Infineon and Microchip. And these are the few awards and recognitions which we received till date. So if anything is there, you can contact us. And one more thing. Today I'm just introducing Mr. Bharat Prakash. He's our technical team. He's from our engineering team, and he's going to give some insights of how this systems like zero export and three-phase system, how it works, and whatever, how they have come to those kind of solutions. And it is basically for these questions are basically say some frequently asked questions, we can say. So these are the we have interacting with the customers, and these are the common questions which we received from the customers, so that we want to share. So welcome, Mr. Banu. Hello everybody. Hello everybody. Prakash. You can introduce.
So I'm working as a finance specialist.
Yeah. So the first about zero export. Okay. Export inverter, how it is different from the grid systems. The normal
A zero export inverter is just like any other grid tie inverter, but the difference comes where the energy is not really pushed into the grid. The load is required. Only so much energy is generated from the PV. So,
okay. And say the question, if the zero export, we are not pushing that energy back to the grid. We are ensuring that it is reducing the electricity bill.
So the electricity much energy is consumed from the grid. So in this case, where we have zero export,
Grid. Because when it comes to a system like a normal customer, and we are connecting the system, and they are having a unidirectional energy meter, which is existing energy meter, right? If we started pushing that, so what will happen? It will consider it as consumption, and their energy bill will go up. Okay, so that is what the main question which comes from the customer is, like, how we are ensuring that. So can you explain us?
sure. So this zero export inverter is actually installed where the power supply is entering into a home.
Okay.
So we'll be monitoring the current that goes through the power supply out of our house.
Okay.
Through the and there we reduce the power generation.
Okay.
To make sure that the current going into the grid is zero.
Okay.
So that's how we do this zero export.
So it ensures that you are not
We don't feed any power to the
any
grid.
power.
Yes. We might consume, but will not feed. In solar is low, we'll consume a little bit, but once solar is high, we'll make sure that the load is matched, and we'll make sure that no current really flows into the grid.
Okay. The next question, the last question in zero export. How is the ThingsCloud system designed to deliver the zero export uniquely, or say better than others? Because nowadays, if you can see, like we started with zero export with built-in. Right now, many people are when Chinese manufacturers, they are coming up with the same scenario. Like now we are also, there's a zero export is there inside. So earlier it was using some separate one, separate external system. So how we are, how you can say that we are unique compared to others.
So the parameter for comparison in this zero export is the response time for the load changes. Says suddenly someone turns off 1 kilowatt of load in the house.
Okay.
So inverter should be adjusting the power of 1 kilowatt in as less time as possible. That's where ThingsCloud, we have given the features where less than a few seconds, like 2-3 seconds, we'll be able to come down so much of power.
So you mean to say our response time is much faster
Much
than
faster than
others?
this.
Okay. So that ensures that we are not nothing is going back. That is good. And now some few questions about three-phase systems. Okay. So what is what is the system you are proposing, like the three-phase system, and how does it compare to a single, or what is the three-phase system, and how does it compare to a single phase?
So the three-phase system is different from a single phase. Just like a single phase comes with the line and neutral. So one will have 230 volts, vary at 50 hertz.
Okay.
So but the three-phase system is different, where there will be three lines. Each of the line will have a potential of 440 volts with respect to each other.
Between the lines.
Between the lines.
Okay.
So that's where the basic difference comes from between single phase and three phase.
Okay.
So that's it.
Okay. So so that is one of the, yeah. So this is one thing, like you are having a 440 or 15 to 440 volt which is there between the. So the next question is, can a three-phase inverter, can we use a three-phase, single-phase inverter to make a three-phase inverter?
So there are two kinds of three-phase systems, basically. One is delta system and the other is star.
Okay.
So in star connected systems, there are two types. 3-phase 3-wire and 3-phase 4-wire.
Okay.
So 3-phase 4-wire systems, the fourth wire is a neutral wire.
Yes.
That is connected to the midpoint of the star.
Mm.
So in this particular case, all three lines can be imbalanced because they are referenced with the midpoint. They can be imbalanced. They can work independently.
Okay.
So in such cases, if we connect a 3-phase inverter, if one phase goes off, the inverter should shut down usually.
Yeah,
If it is a 3-phase inverter.
Yes, yes. True.
But whereas the solution we are providing, we use 3 single-phase inverters which function independent of each other with respect to each phase.
Okay.
In that case, even if one phase goes off, there are 2 other phases running independently.
Yeah.
So that's a basic advantage that we are proposing.
Okay. So why? So that there is a beginning of here. So the next question is like how can we say that is one of the best solution?
So as I said, since all 3 phases run independently, even if one phase goes off, the other 2 will be running. And compared to the cost, having 3 single phase inverters, when you compare the cost of with that of a 3-phase system, it's lesser and comes with an advantage. I can't say it is too less, but slightly lesser and comes with an advantage of running independently.
Okay.
And
So
we have
this is a uniqueness.
yes.
Yeah, compared to all other compared to 3-phase.
3-phase
Right?
inverter.
Okay, so yeah, thank you, Banu. So thank you for your time. And,
Thank you everyone.
yeah, so that's all about today's webinar. So thank you for participating. So please watch, and you can contact us. And there is one more offer, like Diwali offer. So for a zero export system, like say like Tamil Nadu, they buy the system, they buy the grid system, and in later if they get an approval for changing it, you can always ask for us. So then we can change it that to like normal GT. So that is like that is with the nominal charges will be there. But later you can convert that into zero export to normal inverter, normal GT inverter, grid inverters. So if you can order before this November, so it will be easy for you to do that. So please you can send your enquiries, and if you have any doubts, you can call to this number, or you can reach out me through this email ID. So that's it. So thank you all. Thank you for your time. Yeah, thank you. Bye.